Hi guys, and welcome back. I wanted to create a video really quick, just kind of going through this answer key for this Practice FRQ question. I know that we struggled a little bit with these conversions, and unfortunately we don't really have that much time left to really dedicate to doing these because we do have to get through Unit 6 because we still have 3 units to cover before your AP test, which we'll get here a lot sooner than we realize. So we'll do some more practice with these kind of sprinkled in throughout our units as they come up. But for now, I just want to kind of wrap up with this one last example. I will not ask you a calculation question on your test that we haven't done an example of in class, meaning that if you see a calculation on your test, which you will, it will be based on a question we've already seen, or it will be very similar to that. It won't be exactly the same, but it will be close enough that if you have the examples with you, you should be able to use it step by step to help you on your test. And then when we get a little bit more comfortable, we can kind of start branching out and building upon that. But I just wanted to go over this one really quickly. So this one comes from a released FRQ. Which is why I've provided the answer key anyway, because this is already out on the internet. But it says the Cobb family of Fremont is looking at ways to decrease their home water and energy usage. Their current electric hot water heater raises the water temperature to 140 degrees Fahrenheit, which requires 0.20 kilowatt hours per gallon at a cost of 10 cents per kilowatt hour. So each person in the family of 4 showers once a day for an average of 10 minutes per shower. The shower has a flow rate of 5 gallons per minute. So we need to calculate the total amount of water that the family uses per year for taking showers. And if you notice, any time for calculations, you do get 2 points. So 1 point for setting it up correctly, and then 1 point for solving it correctly. So for this first one, it's pretty easy. It's just really multiplying across based on what we know. So we want to figure out how many gallons of water that the family uses per year. So the information gives us how many people are in the household, how many showers they take a day, how long they're in the shower, and how many gallons of water they're using. So really we just need to kind of multiply across. I've set it up for you like we would a dimensional analysis, but you don't have to put them in the fraction form if you can recognize what you're multiplying across. Okay, so we have 4 individuals in the house and they each take 1 shower per day. So we'll do 4 times 1. And then we know that there are 365 days in a year, unless it specifically tells you that it's a leap year and you need to use 366 days. The standard is 365. So we'll do 4 times 1 times 365 days in the year. And then we know each of those showers is 10 minutes long, so we'll multiply by 10 minutes. And then we know that the shower uses 5 gallons per minute, so we're going to need to multiply by 5. And we can kind of see here where our units cancel. Even though this one is like a simple multiplication all the way through, we can still see where we are getting our units canceling out. So our minutes here, because we want to be left with gallons per year. Our minutes are here. Our showers cancel out here. And then our days cancel out here. So we're going to be left with gallons per year. Okay, so that one's pretty simple. So we should get 73,000 gallons per year. Now, the second part of this, and I didn't give the whole FRQ for this assignment, just the calculation portion. The second part of this says the annual cost of the electricity for the family showers, assuming that 2.5 gallons per minute of the water is used from the hot water heater, is what we're calculating. So we're calculating the annual cost. Now, in that first one, we calculated how many gallons were used total. But this particular problem is telling us that only half of the water comes from the hot water heater. So only half of the water used is actually being heated up, which is what we need to calculate. So the first thing we want to do is we want to take those gallons and we want to divide by 2, okay? Because only half of it is coming from the hot water heater. So we need to divide by 2. So we're going to take that 73,000 that we calculated in part 1 and we're going to divide by 2 to get 36.5, okay? Because only half of it comes from the hot water heater. So then we can do a basic conversion, right? So we know that 36,500 gallons are coming from the hot water heater, okay? And we know that it's 0.20 kilowatt hours per gallon to heat that water, okay? So we always want to set it up where our units are in the numerator and the denominator so they can cancel. Okay, so here our gallons are canceling out. So if we were to stop here, we would get the kilowatt hours that are used to heat this water. So we would just get the kilowatt hours per year. If we were to stop there at step 2, instead of getting the monetary value, we would just get the total kilowatt hours. Okay, but we want the cost per year. So we know, based on the problem and what it gave us, that the cost per kilowatt hour is 10 cents. Okay, so here we're going to say 10 cents in our numerator per kilowatt hour in our denominator. And here our kilowatt hour will cancel out. Okay, so what we're going to be left with is the monetary value per year. So if we do this multiplication, we would do 36,500 times 0.20 times 0.10, which will give us $730 per year. So the cost of running those showers for a household of 4 is $730 per year. So the portion of your energy bill that would be a part of the shower, so that the shower contributes to, is $730. Okay, and again, we set this up so that our units would cancel. We took what we knew, and we set it up to where we could get to where we wanted to go. So we started with the gallons. We knew how many kilowatt hours were used to heat each gallon, and we knew the cost of each kilowatt hour. Okay, so we just set them up to where our units would cancel. So we started with gallons, and we ended up with a monetary value per year. Okay, our gallons canceled because gallons were in the numerator here and denominator here. So gallons canceled here. And then our kilowatt hours canceled out here, leaving us with money on the top and a year on the bottom. So $730 per year. So that's the basic setup for most of these calculations. If we can just see where the units go and how they cancel, it becomes kind of a plug and chug, but they still are pretty tricky, so I understand that. But make sure, check your answers, make sure that this is what you got, and if not, we need to identify kind of where we're going wrong. Now, this is just the calculation portion of this FRQ. There was another portion that asked to compare cost and also provide some examples of ways that the family could reduce their cost. You're never going to see an FRQ this short on an AP test. So it's important to get it right kind of the first time, because as we could see in just this calculation portion, it does build on itself. There'll always be areas where you can answer questions even if you don't get the math right, but it's a lot easier if we can start out of the gate getting the correct answer. But that's this question. Again, very similar on your FRQ on your test next week, but if you have any questions, let me know, and we'll just keep on practicing. I hope you have a great day, and I will talk to you guys soon. Bye, guys.